Now, electronegativity is going to determine if our bond is nonpolar, so the electrons are shared equally, or polar, where the electrons are shared unequally. This is very common that they share electrons, but unequally. The more electronegative atom pulls the electrons towards it. Now, if we look at the periodic table, which I know this is getting to be a mess here, but electronegativity increases when we go this way. Fluorine right there is the most electronegative element. So as we move down away from fluorine, electronegativity decreases. So basically fluorine is the electron hog. Okay? And what electronegativity is, a long word to spell, but it's the tendency of an atom to attract electrons in a bond. Okay? Fluorine is very small and has those 7 valence electrons. So it pulls in more electrons. It's the most electronegative. Now, in this pair here, hydrogen and chlorine, chlorine is the more electronegative. So we've got right here, those are lowercase Greek deltas, and that's for partial positive and partial negative. So the hydrogen's partial positive, the chlorine's partial negative. We can also show this by showing a positive charge, like a plus sign, over the partially positive one, and an arrow towards the negative one. And this can show the dipole in the whole molecule. Now we can use electronegativity differences to figure out what type of element, not what type of element, what type of compound we have, whether it be ionic, nonpolar, or polar covalent. Now, you'll see a lot of disagreements from one book to another as to where the cutoff should be for when is it polar, when is it ionic. So I'm actually going to change this, and I'm going to make this 1.8. Okay? Because really what we have is we've got nonpolar, no charges. And then we go to, okay, we've got a plus and a minus. And then we've got a plus and a minus. I was trying to make that bigger. And then we finally have where the plus and the minus are separate. But it's hard to tell where is this break. Kind of like in a rainbow. Where does red end and orange start? It's not a distinct boundary. Okay, so what are you going to do? You are going to find electronegativities in a chart, and you're going to subtract. So let's look at H2O. Okay? Oxygen has an electronegativity of 3.5. Hydrogen has an electronegativity of 2.1, so we subtract and we get a difference of 1.4. Because we're not looking at the whole molecule, we're just looking at, is this bond polar or nonpolar or ionic? And this would be polar. Now to decide if the whole molecule is polar, we need to look at the shape to judge symmetry in addition to this.